We have studied that when a capacitor is connected with a source of EMF, a battery, then it starts getting charged. We know that DC current is not allowed in a capacitor. This is a capacitor. If we connect it with a battery, because of this gap, DC current is not allowed here, but it is getting charged. So when it gets charged, how it gets charged? The charges from the battery, they are pushed because of the energy known as EMF, and the charges reach up to the plates. When the charges reach up to the plate, then the charges have to travel, and when the charges travel, we say the current is flowing. So what happens in a capacitor, whether current is flowing or it is not flowing? The answer is, initially when we switch it on, then some current flows here. I make a resistance here. This resistance represents the resistance in the connecting wires, the internal resistance of the cell, and any other resistance in that circuit. Okay, so that is represented by this resistance R. So when these charges are going there, what happens? We can understand the situation in two manners. दो तरीके से हम इसको समझते हैं. पहला, इनिशियली जब इस पर चार्ज नहीं है तो इसका पोटेंशियल था 0. फिर जब इसमें इसका पोटेंशियल था E बैटरी का, सो दिस वाज E, दिस वाज 0, higher potential, lower potential, charge started flowing from higher to lower, and that forms the current. जैसे ही चार्ज इस पर जाएगा, ये प्लेट चार्ज होगी और इसके अक्रॉस एक पोटेंशियल डिफरेंस क्रिएट होगा. वो पोटेंशियल डिफरेंस ये बढ़ता गया V. तो पहले जो पोटेंशियल गैप था ये E था और ये 0 था, ये E और 0. दिस वाज द पोटेंशियल गैप सो लार्ज. बिकॉज ऑफ दैट उस पोटेंशियल डिफरेंस के प्रोपोर्शन में करंट फ्लो होती थी, बिकॉज I इज प्रोपोर्शनेट टू V. तो यहाँ से करंट स्पीड से फ्लो होती है, पर जैसे ही करंट इसमें पहुंचती है इसके अक्रॉस पोटेंशियल डिफरेंस आ जाता है, और ये पोटेंशियल डिफरेंस करंट को अपोज करता है. क्यों? क्योंकि अगर ये करंट फ्लो कराएगा तो ये ऐसे फ्लो कराएगा, और सेल ऐसे फ्लो करा रहा है, तो इसका पोटेंशियल डिफरेंस इस पोटेंशियल डिफरेंस को अपोज करता है. अगर अपोज करेगा तो ये करंट कम होते चली जाती है. ये करंट कम हो जाती है और चार्ज जाते हैं और पोटेंशियल डिफरेंस बढ़ जाता है. तो ये जो पोटेंशियल डिफरेंस पहले इतना था, अब इसमें भी पोटेंशियल डिफरेंस डेवलप हो गया, तो ये पोटेंशियल डिफरेंस कम हो गया. अब इसमें भी पोटेंशियल डिफरेंस कैपेसिटर में डेवलप हो गया इतना, तो अब ये पोटेंशियल डिफरेंस और कम हो गया. तो जैसे जैसे ये पोटेंशियल डिफरेंस कम होते जाता है, करंट कम होते जाती है. तो हम क्या देखते हैं कि शुरू में जितनी करंट थी, कुछ टाइम तक करंट तो बहुत हाई हो जाती है, ये इतनी तेज चढ़ गई, लेकिन ठीक उतने ही दूसरे टाइम इंटरवल में करंट बहुत थोड़ी सी इंक्रीज होती है ऐसे. उससे अगले टाइम इंटरवल में बहुत ही कम इंक्रीज होती है, और जब इसका पोटेंशियल ऑलमोस्ट इसके बराबर हो जाता है तो पोटेंशियल डिफरेंस दोनों का खत्म, करंट फ्लो होनी बंद. ये तो इस तरह से चार्ज इसमें शुरू में चार्ज बहुत ज़्यादा जाता है, फिर चार्ज और कम, फिर चार्ज और कम, फिर चार्ज और कम. तो ये जो रेट ऑफ चेंज ऑफ चार्ज है dq by dt, dq by dt, दिस इज करंट. ओके, तो इस तरह से एक कैपेसिटर चार्ज होता है. इनिशियली इफ वी डिवाइड इट इनटू डिफरेंट टाइम पीरियड्स, तो शुरू के टाइम पीरियड में चार्ज ज़्यादा फ्लो होता है, उसके बाद के टाइम पीरियड में शुरू में इतना, बाद में और कम, तीसरी बार और कम, और उसके बाद और चार्ज का आना बंद हो जाता है क्योंकि कंप्लीट चार्ज हो चुका है। सो दिस इज हाउ वी अंडरस्टैंड इट। दूसरा तरीका समझने का, शुरू में इसके पास कोई चार्ज नहीं था और बैटरी के पास तो फुल चार्ज होता है जितना चाहिए, तो ये चार्ज यहाँ तेजी से फ्लो करता है बिकॉज ऑफ रिपल्शंस इन द चार्जेस। नाउ if there are two charges here, once they are sent by this, एक बार बैटरी ने चार्ज को भेजा तो ये चार्ज अगले चार्ज को आने के लिए रिपेल करेगा। चार्जेस विल रिपेल द सिमिलर चार्जेस, तो ये दूसरे और चार्जेस को आने के लिए रिपेल करेगा, पर इसका फोर्स ज़्यादा है तो ये चार्ज भेज देगा। देयर विल बी करंट बट इट विल बी लेस। उससे अगली बार इसके चार्जेस और ज़्यादा हो गए, जब ये और चार्ज भेजना चाहता है तो ये और उसको पुश करता है, चार्जेस और कम हो जाते हैं। तो पहली बार जब चार्ज इतने चले गए थे इतने टाइम पीरियड में, दूसरी बार सिर्फ इतने से चार्ज गए, तीसरी बार सिर्फ इतने से चार्ज गए, और जब दोनों का प्रेशर, दोनों की वोल्टेज बराबर हो गई, दोनों का रिपल्शन का फोर्स बराबर हो गया, चार्ज जाना बंद हो गया। उस समय हम ये कहेंगे इसके पास जितना चार्ज आ सकता था आ गया। दिस इज हाउ ए कैपेसिटर गेट्स फुल्ली चार्ज्ड। तो इनिशियली द चार्ज फ्लोज वेरी फास्ट, then it becomes slow and it takes a very long time to get it fully charged, but initially it gets charged, and all this time is in milliseconds or microseconds. So we are studying about that small time period which I am calling milliseconds or microseconds. Okay, उस समय हमको स्टडी करना है कि ये ग्राफ है, what does it show? Charges versus time. कितना टाइम बीतेगा तो कितना चार्ज पहुंचेगा, this we are going to study, and that is charging of the capacitor. Initially टच करते ही फुल चार्ज हो जाएगा? No. Will it wait for a very long time? No. For a very small time it gets charged, but we are studying for that very small time. Okay. Now we come to that calculation. Here is the battery. It has got potential difference. This has got EMF E. EMF. The current flowing at any instant is I, and when the current is I, the time which has passed is T, and at that time the charges on the capacitor are Q. फिर से किसी एक इंस्टेंट T पर यहाँ करंट I हो चुकी है और इसके चार्जेस Q हो चुके हैं। ठीक उस इंस्टेंट पर हम अपनी कैलकुलेशन स्टार्ट करते हैं, एंड हाउ डू वी कैलकुलेट? वी टेक द हेल्प ऑफ किरचॉफ लॉ. The Kirchhoff law says that at any time the sum of all the potential differences will be zero if taken along with the sign. तो देखिए ये सोर्स है, इस सोर्स से एनर्जी और चार्जेस जब फ्लो होंगे that forms the current. At any instant what is the voltage across all the elements, and according to second rule sum of all the voltage across all the elements will be zero. We go by that rule. So let's calculate how much is potential difference across this. So this is V is equal to IR. So this is IR. The voltage across the capacitor is measured by V is equal to Q upon C. So plus Q upon C. This is current is flowing in this direction, this is plus minus, so voltage is in this direction, but when we come here this is minus first and plus, then this voltage will be taken as negative, minus E. This we have already studied in Kirchhoff laws. So this is sum of all the potential differences, and in one loop the sum of all potential differences is 0. So this is 0. Okay, now we have to start with this, and this happens when the time is T. Okay. Now this I, we know it is equal to dq by dt, or this is equal to, take it on this side, this is E, take it on this side, minus q upon c. So this is dq by dt is equal to, this is CE minus q upon c, and here is R. Okay. Now q, dq, they are related, so I put it this way, dq upon CE minus q, because all the functions of q are here, are equal to, dt will go on this side, so this is dt upon R will go here, RC. Okay, so this is the relation of q versus time. Now if we want the value of q, let's integrate both the sides. So this will be integration dq upon CE minus q is equal to integration dt upon RC. We put the limits. How the limits? When we started the cell, the time was 0. When we are taking the observation, the time is t. When we started the cell, the charge on the capacitor was 0. When we are taking this observation, the charge is q. So when the time changes from 0 to t, the charge on the capacitor changes from 0 to q. That is how we decide the simultaneous limits of the two. Okay, now we have to integrate it. When you integrate it, then you will get it integration of 1 upon c minus q. This is function of q, so this will be log natural, and this is CE minus q upon, इसको डिफरेंशिएट किया CE, and this will carry negative sign. This is equal to, this is integration of dt is t, and that will be t minus 0 is t upon RC. ये इंटीग्रेशन डबल स्टेप का इंटीग्रेशन है, and your mathematics teacher can help you out, or you can find out yourself by replacement method. Okay, so log of this is equal to this. Now we know that if we take the antilog of the two, then this quantity is e to the power this. So first let us transfer minus sign here, and this will be log n, log natural CE minus q upon CE is equal to minus t upon RC, and this gives us ये e की power minus t upon RC. This is equal to CE minus q upon CE. ये दोनों का एंटीलॉग हो गया. This. Now this says that CE minus q is equal to CE into e to the power minus t upon RC. Now here take the q on one side and this on this side. So what do we get here? Q is equal to CE minus CE into e to the power minus t upon RC, or we can say q is equal to CE 1 minus e to the power minus t upon RC. This is the expression we were searching for. What does it say? It says there is a capacitor which has got capacitance C. It is connected with a battery of EMF E. Then we start charging it. the resistance of the circuit is R. After t seconds, the charge on the capacitor will be Q, and that Q will be given by this expression. Now we have to understand this expression, and for understanding this, let us put different values of t. इसको अगर हम थोड़ा सा सिंप्लीफाई करेंगे, then Q is equal to CE 1 minus 1 upon, because of this minus, this is 1 upon e to the power t upon RC. देखिए, now relate Q with T. This CE is what? The charge, the maximum charge on the capacitor. How much will be that? Answer is C into V. C into V, V of the battery, is EMF. So C into E gives us the maximum charge, and we can write as Q naught. This is maximum charge on the capacitor. Okay, we can write it Q naught, we can write it CE. So Q is equal to CE, but not full CE. It is always deducted. There is a minus here by this term. So larger is this term, the charge will be less. So let us test it. When time is equal to 0, then how much will be this? So t is equal to 0. 1 minus 1 upon e to the power 0. Anything to the power 0 is 1. So 1 minus 1 is 0. So the charge is equal to 0 when time is equal to 0. Very correct. So when we started, when the time was 0, how much was the charge on capacitor? 0. Now if we take it, time is equal to RC. जो भी R की वैल्यू है, जो भी C की वैल्यू है, मल्टीप्लाई किया, T is equal to RC. At this time what will happen? This Q is equal to CE 1 minus 1 upon, and this is T is equal to RC, this will be 1 E. And here we put the value, you know the value, it is CE 1 minus 1 upon 2.37, so. Okay, if we solve it, this will come to 0.67 of maximum charge on the capacitor, 0.67. So this is the charge when the time is equal to RC. Now this has got a very important figure, that when time is equal to RC, the charge reaches 0.67 CE. Now again, if we take the time is equal to 2 RC, T is equal to 2 RC, and when the time is equal to 2 RC, I have solved it, it will come to be 0.86. Yes, this will be 2, e to the power 2, e to the power 2 is 2.37 to the power 2, और उसको करने से ये कितना आ जाएगा? 0.86 of the maximum charge. Yeah. So एक t टाइम पर, एक RC टाइम पर चार्ज कितना? 0.67, more than half. और अगर ये टाइम को डबल कर दें तो चार्ज डबल नहीं होता, इट इंक्रीजेज वेरी स्मॉल क्वांटिटी, 0.86 ओनली. ओके, इफ वी टेक t इज इक्वल टू 3 RC, then charge will be again very small, and at 4 RC it is almost 1, but not 1. So here we find, if we are going to increase the value of t and we want full charge, अगर ये फुल चार्ज हमको चाहिए तो इसको 0 हो जाना चाहिए। और 0 के लिए क्या कंडीशन है? 0 के लिए कंडीशन है that t should be infinite. This denominator should be infinite, then only this will be 0. So t should be infinite. That means the total charge up to the capacity of capacitor when it will be actually charged after a very, very long time. So mathematically it will be a very long time, but practically what we find that after 4t it is almost fully charged. So but the value keeps on changing. So when we make a graph of it, here is time and here is charge. We take 1t here, t, and this t we know is equal to RC. Then this is full charge, Q naught, let us say. Then this is 0.5, this is 0.6, and this is 0.63. This. After 2t, same t here, 2t, this is 2RC, and this becomes 0.86. This is 0.9, 0.86 here. After 3t, it becomes 0.9 something. And after 4t, it is here. So we get a graph which is this. So this is Q naught. We will see that it goes like this and never touches that, because where it is supposed to touch when time will be equal to infinity. Therefore we will show it is never touching here, but at 4t it is almost to the maximum value. 4t, 5t, it reaches the peak value, maximum value. So this is the graph of charging of capacitor. This is formula for capacitor charging. We will write it this way, and this time period when the charge reaches 0.67 of the maximum charge, this time is known as time constant. Time constant of capacitor. So this is time constant of capacitor. Okay, right. So this is charging of the capacitor, and now when we discharge it, what happens? When we discharge it, there is no cell. How do we discharge it? There are two plates of capacitor. Put a conductor across it, and all the charge from plus to minus will go there. Yes, there may be certain resistance in the circuit, in the conductor, and because of that resistance there will be a finite current passing through it, and the full charge, which was Q, goes on decreasing till it finally becomes 0. That state is known as full discharge. And now we will see the discharge process of a capacitor. Okay, we have a capacitor which is fully charged. Here is a capacitor fully charged. It has got charge Q. Now I want to discharge it. For discharging, what do? We short it this way. This conductor may be having certain resistance. Let us say this resistance is R. And now when we short circuit it this way, the charges flow this way. And for discharging, we don't need any cell, any battery. So because these charges are going here, there is a instantaneous current for a very small time, and let this current at any instant is I. Now the charge is flowing through this. Let the charge which is flowing here will decrease it. This, ये जो Q चार्ज है ये कम होते चले जाता है. ओके, Q, this goes on decreasing and it has to go to the level 0. Time T has passed after short circuit और ये चार्ज कम होते होते T टाइम पर Q हो गया. Q थोड़ी देर बाद 0 हो जाएगा. ओके, T टाइम पर ये चार्ज Q हो चुका है. उस समय at that instant we make our equation. At that time what is the value of current I? So again we take help of Kirchhoff law. इसके across potential difference कितना है? V is equal to IR. इसके across potential difference कितना है? V is equal to Q upon C. और in this loop what will be the potential difference? That is, और यहाँ पर sum of potential 0 किया तो यहाँ पर उस समय चार्ज कितना है? Q, small q. तो इसकी वोल्टेज कितनी होगी? Q upon C. Take care that it is a small q because when the time is t, the charge is Q. So Q upon C is the potential difference across this. I into R is the potential difference across this. So the sum of potential difference, that is Q upon C plus I into R, is equal to 0, or we can say Q upon C is equal to minus I into R. And this is very natural because इसका potential इस direction में है, इसका potential ये current के कारण इस डायरेक्शन में है. दैट इज वाई दिस माइनस इज देयर. सो Q अपॉन C इज इक्वल टू I अपॉन R, एंड दिस वी कैन राइट एज dQ by dt into R, Q upon C. So we take the Q functions on one side. So dQ upon Q is equal to, this will go here, this will go here. So dQ upon Q is equal to dt upon RC, and minus. Now let us integrate the two and apply the proper limits. Integration of dQ by Q is equal to integration of minus dt by RC. The time started from 0 to t. When the time was 0, how much was this variable charge? The answer, when time was 0, it was fully charged and the charge was Q. So when the time was 0, the charge was Q. And when the time is t, the charge is Q. Okay. So time 0, starting charge, fully charged Q. When there is a discharge process keeps on taking, the time as t, the remaining charge is Q, remaining charge. Okay, now we integrate both sides. So this will be log natural Q is equal to minus t 0 t, and this is 1 upon RC. I will write it here. Okay. So again we can make it, this is natural log Q minus log Q is equal to minus T upon RC. This will be log natural Q upon Q is equal to minus T upon RC. So Q upon Q is equal to e to the power minus T upon RC. ये mathematical transformation आप सबको मालूम है. Okay, so how much is the Q when the time is t? This is equal to the full charge initial multiplied by a factor which is e to the power minus T upon RC. This is the remaining charge. This is equation for remaining charge. After time t, how much is the discharge? The answer is the discharge will be how much charge has flown out. Initially the charge was Q, and how much is the remaining charge? This Q into e to the power minus t upon RC. So this is the discharge. And how much it is? Q, that is 1 minus e to the power minus t upon RC. This maximum charge was how much? C, 1 minus e to the power minus t upon RC, and this is a well-known equation to you. What is this shows? Discharge after time t. How much was the charge after time t? Same. How much is the discharge after time t? Same. So please remember the two terms. How much charge has flown out of capacitor in time t? This much is flown out. Discharge. Flown out. How much is remaining? This is the remaining. There is no 1 minus. So this is the remaining charge. This is the flown out charge. And from here, we can make the graph. In time t, initially the charge was Q, which is maximum charge, and it goes on decreasing. Here, when t is equal to RC, you can find it out how much will be the charge. I will write it here this way, simplified. Q is equal to maximum charge Q to be divided by e to the power. This because of this minus, ये नीचे आ जाएगा और e की पावर क्या हो जाएगी? T upon RC. तो जब T RC के इक्वल है तो ये कितना हो जाएगा? 1, and this will be Q upon 2.37, and that will come to 0.3. Okay, that was 0.67. Yes, T, and this will be 0.33. This is 0.33. In T, what is T? T is equal to RC, time constant of the capacitor. So the charge has come from this point to this point. When we make it 2T, then we put it 2RC upon RC e to the power 2, and it comes here 0.86 less than this. Here will be 0.14. 0.14 is somewhere here. And we get a graph like this. This way. This is 3, this is 4. And how much T is equal to? RC, time constant. So this is discharge. Discharge of capacitor. So in one time constant, it reaches the value 0.33. So this is the two, there are the 2 points you must remember. In one, what is time constant? How much? Answer, R into C. What happens in a time constant? Answer, when we are charging it, the 0.67 of the maximum charge is charged in one time constant. And when we are discharging it, then 0.67 is discharged and 0.33 remain in one time constant. So this is the process of charging and discharging of capacitor. Thank you.